Hello everyone, I am Dr. Sanjeev Punia. We are discussing about 3D concepts and object representations. In this, we discuss about polygon surfaces. In polygon surfaces, we discussed about polygon table in last lecture. Today, we will discuss about plane equation and polygon meshes. So let's start about the polygon representation. As we discussed that when we have to represent a polygon, then there are different ways. In last, we discussed about the polygon tables. Now about the plane equations and polygon meshes, we will see that how we can represent and work with these techniques. So this was the thing that we discussed, that how we can represent a polygon in forms of tables using vertex table, edge table, and polygon surface table. And what's the problem with this? So to overcome that problem, we switch over to plane equations. So this is for producing display of 3D objects. We must process the input data representation for the object through several procedures. Sometimes we need to find orientation, and it can be obtained by vertex coordinate values and the equation of the polygon plane. As we know that equation of a line is ax plus by plus c is equals to 0. In the same manner, the equation of a plane is ax plus by plus cz plus d equals to 0, where x, y, and z is any point on the plane in x direction or on x coordinate, on y coordinate, and on z coordinate respectively. And a, b, c, and d are the constant in this. So this is a basic representation of a polygon using plane equations. Now we can solve these equations. There are different ways to solve these. Suppose I am writing the equation for the first coordinate using ax plus by plus cz plus d equals to 0, then we can divide it as I'm writing the equation. The equation was ax plus by plus cz plus d, this is plus d equals to 0. So when I will change this d, or when I will bring this d from this side to right hand side, then in that case here it will be 0 and this will be minus d in the another side. And to get a 1 over here, I will divide this whole using the d. So this will be a plus a divided by d, as d is also a constant. So this a divided by d is also a constant, multiplied by x plus b divided by d, b divided by d plus c, sorry, this is y also. This is multiplied by y plus c divided by d and multiplied by z equals to minus 1. Minus 1. So we solve these equations by solving these equations for three planes. And three planes are non-two linear points, so solve simultaneously, that is for a by d for the first plane. This is for the first plane, x1, y1 and z1, whereas for the second plane it is x2, y2 and z2, as well as for the third plane it is x3, y3 and z3. So first we write the plane equations or the polygon equations in, or we can say that first we represent the polygon using three different plane equations. Now we can solve these equations. There are different ways to solve these equations, but I think determinant is the simplest method to solve any type of equation. So by using the determinant, when I want to find out the value of a, then in that case it is 111 from here. This is 111 in second column. This is y1, y2, y3, y1, y2, y3. And in third one, this is Z1, Z2, Z3. But keep in mind one thing, that when I am calculating the value of Z, in that case, this is minus. Before this determinant, I am using minus because this value is in the minus. The value of D is in the minus. So this is the reason that the value of D is going to represent by minus into determinant for D. So by expanding a determinant, we get for the value of a, that is a equals to y1 z2 minus z3 plus y2 z3 minus z1 plus y3 z1 minus z2. So this is the solution of a equation to check the value of a. In the same way, we can find the value of b using extending the determinant, that is z1 in bracket x2 minus x3 plus z2 in bracket x3 minus x1 plus z3 in bracket x1 minus x3. Same we apply for C also. But in case of D, again you can see that this, first of all, this is minus. This is also minus and this is also minus, as we discussed in the case of determinant for D. And over here, this is x1 multiplied by y2 into z3. This is y2 into z3 minus y3 into z2, whole bracket multiplied by x1. And again minus x2, this is for x2 value, so minus x2 in bracket y3 z1 minus y1 z3. So these values are going to be interchanged, and this is y3, so this is y1, this is z1, so this is z3. Same over here, you can check that this is y1 and this is y2, this is z2, this is y1. So the values is going to change over here, only the difference is of sign between these two. So this value of A, B, C and D are then stored in polygon data structure with other polygon data. So this was the representation of a polygon using plane equations. Now, if we have a plane, then there are the way in which we can orient the plane. Suppose this is a plane, you can see over here that this is a plane n equals to ABC, then there can be the different type of orientation with x-axis, y-axis and z-axis. So orientation of a plane is described with normal vector of the plane. Suppose this normal vector is going to change its position, then the angle that is made by this plane is going to be changed. Here n is equals to ABC, where A, B and C are the plane coefficient. Normal vector n can be calculated for any particular surface by cross product of two vectors in counterclockwise direction in right-handed system. As we discussed that there are two different ways to represent a three-dimensional vector. First one is left-handed system and second one is right-handed system. And over here, generally we use right-handed system to represent 3D object. So normal vector n can be calculated for any particular surface by cross product of two vectors in counterclockwise directions. So, and if we want to represent this plane, then the representation of this plane in the form of plane equation is n equals to v2 minus v1, means vector v2 minus v1 divided by multiplied by vector v3 minus v2. Sorry, v3 minus v1. So this is the way in which the value of n can be found. So n gives value of A, B and C for that surface. D can be obtained by putting these values in plane equation for one of the vertex and solve for D. As we know that these are the different equations of the plane. Using plane equation in vector form, we can obtain the value of D as the multiplying of n with vector P is equals to minus D. So from here we can find out the value of D, that is equals to minus n with the product P. So the plane equation is also used to find position of any point compared to plane surface as follows. So now we can find out that the point is either in the same plane or outside the plane or not in the plane. So if the value of the equation, that is ax plus by plus c plus z, is not equals to 0, it means the point xyz is not on that plane. If the value of this equation is not equals to 0, means for a point to be on the plane, value of this equation, value of representation of the 3D equation should be 0. And if the point is inside the surface, then the value of ax plus by plus cz plus d should be less than 0. And when the point is outside the surface, then this value should be more than 0. So when the value of the equation is 0, it means the point lies on the surface. If not equals to 0, it means the point is not on the surface. And that is either inside the surface or outside the surface. Now we will discuss about third point, that is polygon meshes. As we discussed in starting, that polygon is also a collection of different faces or surfaces. Same way, polygon mesh is a collection of edges, vertices, and faces that defines the shape of the polyhedral object in 3D computer graphics and solid modeling, as each and everything is going to be represented on the computer screen, and we have to find out the different way to make the representation better and better. So an edge can be shared by two or more polygons. In this case, vertex is shared by at least two edges to make a surface. Polygon meshes is represented in following ways, either in explicit representation or in pointer to vertex list or pointer to edge list. As you can see over here, that these are the different surfaces, and from here we can create a mesh of the planes based on the representation and as with respect to vertices. When we have to draw any cartoon or something as a character of a video game or mobile game, in that case, a person is going to represent in such a form that it is the collections of different polygon meshes. So this is the concept, and it can be represented by polygon vertices in the order of memory by the collections of different coordinates or each and every coordinate in the form x1, y1, z1, as this is the coordinate of one point of the polygon mesh. This is the another point, this is the next point, and this is the last point. It processes fast but require more memory for storing the object. For an example, you can see the last example, that is there are two planes P1 and P2 and there are four vertices. In this case, we have to store, this is 1, 2, 3, 4, 5 and 6. That is 1, 2, 3, 4, 5 and 6. So information stored in this has to be, we have to store a lot of informations, so the system becomes slow. So in this method, each vertex stores in vertex list and then polygon contains pointer to the vertex list. So first we have to store the vertex, then it contains the pointer of that vertex. Now polygon of vertex 3, 4, 5 is going to represent as P is equals to V3, V4, V4, V5 and V5, V3. It is considerably space saving when we perform the operations in this way, but for finding common edge we require lot of extra work. For an example, you can see over here that to find this edge, it's really difficult to find out the value of E2. So this is also the way that is going to be enhanced for vertices, edges, and for the point P, where P contains the edges E1, E2, EK means all the edges, and edges contains the vertices, that is V1, V2, V2, V3, in combinations of all the vertices, and vertices contains the coordinates, all the coordinates, that is x1, y1, z1 in this way. So this approach is more memory efficient and easy to find common edges. As you can see over here, we discussed that in P we store only edges, as I told you over here. In E we store only, in E we store only vertices and we store only coordinates in V, that is vertices. So this was complete about the polygon representation. We discussed about Bezier curve and surface earlier. So I hope that we have discussed each and every point of all the units. Now, if you will see, then we will discuss point by point that what we have done and what we do not have done. So I will repeat the things point by point in the next lecture so that it will be more clear that we have done our syllabus completely. Otherwise, this is the last topic, that is polygon representations. Thank you. Thanks a lot.